The following is a collection of strange code snippets in Python and an explanation of why they work the way that they do. More often than not, people behave with their Python code, although sometimes they don't. These are their stories. You're familiar with functions, right? If I say print out 5, it prints out 5. If I say bin of 3, it returns a string that is the number 3 in binary. If I say pow of 2 comma 3, that does exponentiation, raising 2 to the third power, or 8. You're also familiar with variables, right? I can make as many variables as I want. X equals 1, Y equals 2, Z equals 3. But what happens if functions start becoming variables? Certainly there's something in Python stopping you from turning one of its built-in functions to a random string, right? You'd be wrong. I can print bin of 6 and get 6 in binary. Then I can just store the string British bloke in the name of the function bin as a variable. From then on, bin just works like any regular variable. Of course, don't actually do this in your code. It's good to know that this is possible, though, to be able to track down bugs. Now you know that you can just assign random values to function names, and they'll act as variables. If you're not already familiar, Python takes the road less traveled when it comes to the Boolean values true and false. True and false must be capitalized in Python. It's this very fact that opens up a strange backdoor in Python. You can do lowercase true equals false, and then lowercase false equals true, and then do all sorts of nonsense like true or true that ends up being false. All this is possible because uppercase true and false are the Boolean keywords that can't be changed, so the lowercase variants of the Boolean keywords are just possible variable names. Obviously don't do this in your code because true and false means specific things in code, and using them as variable names would no doubt mess someone up. If you don't already know what the is operator does in Python, I'll demonstrate it. We'll declare a list variable, list A and list B. Both lists are the empty list. When you write A is B, the question you're asking is, and this is a slight simplification, is the memory address of A the same as the memory address of B? If that's the case, A is B would result in true. Otherwise, it would result in false. Obviously, you want two lists to exist at different memory addresses so they can be modified independent of each other. So A is B returns false. What happens if we change this up slightly, though, and swap out the empty list with empty tuples? A is B would still return false because you want the tuples to be able to be modified independent of each other, right? Well, if you know your Python, you just caught where I went wrong. Tuples are immutable, meaning they are never modified. This behavior is defined in the language, so when two of the same type of immutable values, like empty tuples, are declared back to back, Python performs a memory optimization where the second time you declare an empty tuple, that second variable is just a reference to the value that the first variable already references. So A is B returns true. If you don't already know what sets are in Python, I'll demonstrate them. Something like set A, holding 1 through 3, is fine and dandy, no problem. Sets can also hold mixed types, so set B equals string 1 and then number 1 and 2 is also fine. What isn't fine is something like set C equals 1, 1, 2, 2. Sets big things are big containers that can't hold any duplicates. The way I phrase this next question is very important. Are 5 and 5.0 the same thing in Python? Well, yes, but actually no. If you understand the type system in Python, you know the 5 is an int and 5.0 is a float. So by the apple and oranges concept, one apple and one orange can never be the same thing. Coming at it from a different lens, though, the two values are numerically equivalent. Going back to sets, equality is a determining factor on whether or not an element in a set is unique. So when you do a set that holds 5 and 5.0, and its length is only 1, what you're getting back is that the 5.0 was never added, as it was considered to be a duplicate of the 5 that was already there. If you flipped around the declaration and put the 5.0 and then the 5, a similar thing would be true. The 5 would never be added because it was considered to be a duplicate of the 5.0 that was already there. If you don't already know what none is in Python, I'll demonstrate it. The easiest way to get none is to have a function that doesn't return anything. If you tried to print out that function's return value, you'd get a blank printout. That's because none is a constant object that is the absence of any value, In a way, it's the identity of nothing because you can never have nothing in code. Expanding on none, we have the is operator. Is tells you if two objects are the same in Python's memory. It turns out that none, it is always the same object in memory, so none is none returns true. I'll have a video in the description for you to learn more about none. Last, there is the is not identity comparison operator. Doing none is not none would give you the opposite of doing the comparison without the not, so false. In all scenarios, is not will give the opposite value of is. Okay, putting it all together now. One is not none reads as, okay, are one and none identical? Obviously not, but we're doing is not, so the opposite of obviously not is of course, and true is returned. One is parentheses not none throws a surprise wrinkle in there. Is not is one single operator that works a certain way. Evaluating the not separately works differently. Here, the not converts the none to a boolean, which will be false, then flips that boolean and results in true. You're left with one is true, one and true are not identical, so false is returned. If you learn nothing else, be wary of parentheses because they can change what a line of code does. If you've gotten here to the end of the video and you want to learn more Python step by step, I have a playlist you can click into on the screen now or in the link in the description. Ciao.